Welcome to the question number 39. A sheet is placed on a horizontal surface in front of a strong magnetic pole. A force is needed. A. Hold the sheet if there is magnetic. B. Hold the sheet if it is non-magnetic. C. Move the sheet away from the pole with uniform velocity if it is conducting, and D. Move the sheet away from the pole with uniform velocity if it is both non-conducting and polar. So if it is magnetic, then only we have to hold the sheet, and definitely when it will move, it will move with a uniform velocity if it is conducting. So option A and C are correct. From the option 1, A, C and D, number 2, C only, number 3, B and D only, and number 4, A and C only. So A and C are the correct option, number 4, for this question number 39. Next question number 41. A small telescope has an objective of focal length 140 cm and an eyepiece of focal length 5 cm. The magnifying power of telescopes for viewing a distant object is 17, 32, 34 or 30, 28 as per the options present. As you know, magnification equals to FO by FE, that is focal length of object piece by focal length of eyepiece. It is given as 140 by 5, so it is equal to 28. So option number D is correct.
Question number 40. A parallel plate capacitor is charged by connecting it to a battery through a resistor. If I is a current in the circuit, then there is a gap between plates. Number 1, displacement current of magnitude equal to I flows in a direction opposite to that of I. Number 2, displacement current of magnitude greater than I flows in any direction which is greater than I. Displacement current of magnitude greater than I flows but can be in any direction. Number 3, there is no current. And number 4, displacement current of magnitude I flows in the same direction as I. So as you know, when a parallel plate capacitor is there and a current is passed, there are two type of current flows. That is displacement current, and another is a conducting current. So here displacement current also should move in the same direction as I move. So option number 4 is correct. Number 43. We are skipping, but again we are coming to the same point itself. A metallic bar of Young's modulus 0.5 into 10 to the power 11 Newton per meter square, and coefficient of linear expansion 10 to the power minus 5 per degree centigrade. Length 1 meter and area of cross section 10 to the power minus 3 meter square is heated from 0 degree centigrade to 100 degree centigrade without expansion. So the compressive force, so expansion or bending, the compressive force is number 1, 100 into 10 cube Newton, number 2, 2 into 10 cube Newton, number 3, 5 into 10 cube Newton, and number 4, 50 into 10 cube Newton. So these are the options that you can see here. Options are this much. So as we know, there is a formula F equals to YA alpha T, that is compressive force equals to Young's modulus into area into coefficient of thermal expansion into time, temperature difference. So y is 0.5 into 10 to the power 11 into 10 to the minus 3 into 10 to the minus 5 into 100 as per the possible. 10 to the power 11 to 10 to the power minus 3 is 10 to the power 8. So 0.5 into 10 to the power 8 into 10 to the minus 5 into 100 is 10 to the power minus 3. So that is 0.5 into 10 to the power 5. That will give you 5 into 10 to the power 4. That is 50 into 10 cube Newton. So option number 4 is correct.
The question number 42. The velocity v time t plot of the motion of body is shown here. This is a figure, and these are the options: acceleration time, acceleration time, acceleration time, acceleration time. So this part, that means it will go up, and this type constant, and this type is deceleration. So that means it will go in the negative direction. This is positive direction, this is constant, and this is negative direction. You can see here acceleration is going up and again down here itself, and here it is constant. That means this part is turning this part. So velocity constant, that means the acceleration is 0, and here again acceleration is negative, it is deceleration, it is coming downwards. So option number 1 is correct. Let us see if option number 2 is incorrect. Is not possible, negative it is there. Number 3 again same as velocity time graph, which is not possible. And number 4 again acceleration time graph is not there because it is not same as velocity. So option number A is correct. Next question number 44. A 10 microfarad capacitor is connected to 210 volt
50 hertz as shown in the figure. The peak current in the circuit nearly pi equal to 3.14 is this is a circuit. So option D 1.2, 1.35, 3, 1 and number 4 0.93 amps. Now you can see, as we know, current equals to E by XC. X is the reactance offered by the capacitor. So there is equal to E by 1 by twice by FC. So that is equal to twice by FCE. So that is equal to 2 pi means 6.28 into 50 hertz into 10 to the power minus 10 into 10 to the minus 6 into 210. So it is coming 6.28 into 0.105 amps, and since it is peak current, so it is root 2 times of I. So that is will give you root 2 into 6.28 into 0.105, that will give you 0.93 amps. So option number D is correct, or number 4 is correct.
Question number 45. Two heaters A and B have power rating of 1 kilowatt and 2 kilowatt respectively. Those two are first connected in series and then in parallel to a fixed power source. The ratio of power output for these two cases is option A 1:2, number B 2:3, number C 1:1, and D 2:9. So power in series can be given as P1 P2 by P1 plus P2. So 2 into 1 by 2 plus 1. It is given equal to 2:3 watt. And power in parallel will give you P1 plus P2, that is 2 plus 1 watt. So it will be 3 watt. So PS by PP equals to 2:3 divided by 3. So that will be 2:9. So option number D is correct. Next question, 46. A force defined by F equals to alpha t square plus beta t acts on a particle at a given time t. The factor which is dimensionless if alpha and beta are constant. So option 1 is given alpha bt, number 2 alpha beta by t, number 3 beta 2 by t, beta t by alpha, and number 4 alpha t by beta. So as we know from this equation, alpha t square dimension has to be same as F, and same goes to beta into t. So alpha t square equals to F. So alpha equal to F by t square. So alpha equal to F by t square. So similarly beta equal to F by t. So now we have solved by each and every option. So alpha beta into t will give you F square by t cube, which is not possible, is not coming dimensionless. Number 2 alpha beta by t will come F square by t cube, which is also not same. Sorry, F square by t square, which is not coming. Number 3 beta t by alpha will give you F by t square, which is coming t square, which is also not possible, and option last. Number 4 alpha by beta into t, which is coming F by t square divided by F by t whole into t. So it is coming 1. So option number 4 is correct, which is dimensionless. Question number 47. The property of wave which is not EM wave, that is electromagnetic wave, traveling in free space is that A, they travel with speed equal to 1 by root over mu naught epsilon naught. Number 2, they originate from charges moving with uniform speed. Number 3, they are transverse in nature. And number 4, energy density in electric field equal to energy density in magnetic field. Now same one thing I will say, that all 3 points are correct. That is, they travel with a speed of equal to 1 by root over mu naught by epsilon naught. That is also correct. They are transverse in nature. That is also correct. Energy density in electric field equal to energy density in magnetic field. That is also correct. So option number 2 is correct. But here it is not the electromagnetic wave. That is, that doesn't matches with the property of electromagnet. So that means they originate from charges moving with uniform speed. So acceleration here is 0. So it moves in uniform speed. So this is number 2. Option is correct. Number 48, an iron bar of length L has magnetic moment M, is bent at the middle of its length such that two arms make an angle 60 degree with each other. The magnetic moment of this new magnet is that if a magnet is inclined at 60 degree, suppose north pole and north pole, so definitely it will be a repulsion. So definitely the angle between the resultant will be 120 degrees. So M dash equals to root over a square plus b square plus twice ab cos theta. So m by 2 whole square plus m by 2 whole square plus twice into m by 2 into m by 2 into cos 120, and cos 120 is minus half. So here it will be m by 2 whole square plus m by 2 whole square minus m by 2 whole square. So answer will be m by 2. So option here 2m m by root 3 m and d m by 2. So the option D is correct. M by 2 is the correct one.
Question number 49. If mass of the bob in a simple pendulum is increased to thrice its original mass and length is reduced to half of its original length, then the new time period of oscillation is x by 2 times original time period. The value of x is how much? First of all, t equal to 2 pi root over L by g. Now tell me, will mass depend on this time period? No, sir. So t varies is only root L and t varies is 1 by root g, but it is not mentioned, it is not needed here. So t1 by t2 equal to root over L1 by L2, as L2 is equal to L1 by 2. So root over L1 divided by L1 by 2, so it is coming root 2. So now t2 equals to x by 2 into t1 as per the demand of the question. So t2 by t1 equals to x by 2. So x by 2, and that is equals to t1 by t2 equal to root 2. So t2 by t1 equal to 1 by root 2. So x equal to 2 by root 2, that is equal to root 2. So option number 4 is correct. Options are values of x is 2 root 3, number 1, number 2, 4, number 3, root 3, number 4, root 2. So option number 4 is correct, root 2. Last, this question. The minimum, number 50, the minimum energy required to launch a satellite of mass m from the surface of the earth of mass big M and radius big R is a circular orbit at an altitude of 2r from the surface of the earth is A, g big M small m by 2r, B, g big M small m by 3r, C, 5/6 of g big M small m by r, D, 2/3 of g big M small m by r. Now we know potential energy equals to minus gmm by r and ek equals to gmm by 2r. So total energy of the satellite E equals to ek plus ep, that is equal to ek plus ep is equal to minus gmm by 2r, gmm by 2r minus gm. So here it is required minus gmm divided by 2 into r plus 2r. Here we have not put the minus, so you should put it minus here. So minus gmm by r 2 into r plus 2r. So it is coming minus gmm by 6r. So it is coming here minus gmm by 6r. And here ep equals to gmm by r. So when we will add up this one, so here we can get it ek plus ep. So total energy we can do like these things. So equals to g big M small m by 6r minus gmm by r. So it will come minus 5/6 of g big M small m by